This is bad. You think we should be better at these languages so that we can answer these questions before we
Dude,
go, or better
you,
prepared
you
at least?
just you just started. How many, you had like what, 2 weeks on this or something like that, and never looked at Elixir before? Come on.
Okay, welcome. This is proglangcast, episode 11. This is our Bye Hello World application written in Elixir. For those of you who may or may not have been following along, I'm Steve Thames,
I am Christopher Augustus.
and this is our third language that we've done in a functional language. We started with F#, we then did Erlang, and now we're taking a look at Elixir.
Scheme is technically a functional language.
Right, okay, so Scheme is a functional language as well. So this is our fourth language. We're doing this one in Elixir. Elixir was written by a fellow named Jose Valim, who is an electrical engineer and a computer engineer. And he was working largely at the beginning of the century. He was working largely in the Rails project, Ruby on Rails. And it was at this time that Jose realized that in the past, when you could write one program and then wait a year for a much more powerful computer, a much more faster chip, that it would double your processing speed. And in the beginning of the 2000s, he realized that this was stopping. We were no longer doubling processing power. And he was working in Ruby on Rails, which is a web application framework, and realized that what he needed in order to continually enhance performance of a system is concurrency. And so he started looking around for what would meet that requirement and found Erlang, which is built specifically for concurrency. If you want to know a little bit more about Erlang, you can look at a previous version of proglangcast in which we talk about an Erlang version of Bye Hello World. And he wanted to bring that kind of processing to the web application development environment. And being very familiar with Ruby, in fact, he was a core member of the Rails team, he decided to write it in a Ruby style syntax. So Elixir runs in the Erlang beam and is fundamentally, for the most part, written in the syntax of Ruby. One of the things that I found interesting was that in the Elixir syntax, the immutability of Erlang has been overridden. You now can use variables multiple times, where you can't do that in Erlang.
Do you have to do anything special to make that happen? You could just do it anywhere.
You don't have to do anything special. You don't have to specify that a value is mutable like you have to in F#, for instance. You can just use it again. And in Elixir, they call it rebinding. And to my mind, that's, a rose by any other name now makes all the variables mutable.
There is a difference between rebinding and modifying the value that the current variable points at in memory, if that makes sense.
I think that's the point that they make with the term rebinding. Like if you say a equals 10, for instance, and then if you say a equals 20, you're not actually changing the memory location of the a was pointing to, which is now 10. You're not changing it to 20. You're actually taking a and now saying it points to a different location in memory. Okay, so what I've done now is we've loaded up the WSL shell. We're going to go into Erlang. This is the Erlang shell. Say a equals 10.
It has to be a capital A.
Right. Thank you very much. That has to be a capital A. Another difference with Erlang and Elixir, which we'll talk about in a minute. So a equals 10. Now I have now bound the value of a to the variable a to the value of 10. So if I now say a equals 20, that's going to throw an error because a has already been bound to a value and is not mutable.
Or rebindable. Yeah.
For example, I could say b equals 20, and that works fine.
And can you say b equals, well, you can't say b now, you've bound it.
But I can do this, and that's going to come back 20.
Because that's actually a match.
That's doing a match.
Yeah.
I can say
Does b equal 20?
10, and that's going to say it's an exception because there is no match
Doesn't match
between b and 10.
Technically, the equal sign is always a match compare. It's just if a variable has not yet been bound, it uniquely says, okay, you're telling me to match it to.
Let's jump out of this and let's go into the Elixir Shell.
So what did you type?
IEX is the Elixir Shell.
IEX.
Okay, so let's try the same thing again, except now we can use lowercase for variables, and I don't need to specify a period.
No
So
period.
a little bit of difference there. In the Erlang Shell, everything's terminated with a period. In the Elixir Shell, it is not. In Erlang, an uppercase letter denotes a variable. A lowercase letter denotes an atom.
An atom.
Right. Whereas in Elixir, a lowercase letter denotes a variable, and anything starting with a colon denotes an atom. And we'll see that when we look at the code. I've now got my value of a, lowercase a, which is 10. I can now say a lowercase a equals 20. That's
you did.
That's a perfectly valid in Elixir.
And it changes to 20.
Mm-hmm.
And that's a rebinding, because you're not going to change the value of a constant to another constant.
You're not changing the value at that location.
Yeah.
You're rebinding it. You're saying point this to another location. That's one of the fundamental differences between Elixir and Erlang, is that in Erlang variables are all immutable. Once you set them, you cannot change them. In Elixir, that's different. Let's see how this tool works. I'm going to say run 5, and then that's going to run Bye Hello World for 5 iterations. So what we see is I've typed /run space 5, and the output comes up world, hello, ... 5, ... 4, ... 3, 2, 1, and then bye, period, which is the standard signature of our Bye Hello World program. I can run it without parameters, /run, and it will come up and ask me for the iteration countdown that I want to use. Let's enter frog. Whoops. Frog. Invalid countdown.
My favorite.
Frog
my
in
favorite
quotes.
Invalid countdown.
Invalid countdown, quote, frog, quote, colon, try again. So now I'm going to let's put in a valid number, but an invalid range, which is -1. Invalid countdown, -1, not in quotes. Try again. Quotes. And there's a reason for that, which I'll demonstrate. Let's do an invalid.
We tend to harp on that.
What's that?
We tend to harp on when the invalid has quotes and doesn't have quotes.
We found there was a special formatting signature in Erlang. It would output it to the format of the variable, and I'll show you what I did to accomplish the same thing. I'll put in 0, and which is valid, so we get world, hello, ... bye, period. Okay, so let's try some other values. I'm going to do a /run 1.1. And I get an invalid quotes. Countdown in quotes.
But the -1 was not in quotes.
I'm going to confess, this is not something I tried before. So my little mechanism for doing that, it doesn't allow for that.
See?
The 1.1 doesn't work. You want to try a square root or something, or maybe an exponent?
Yeah.
They're all just coming in as strings.
Okay, how about a really big 9? Huge number.
You want to do something like this.
Really long. Really long. Keep going. Let's see how big of an integer it can handle. All right, stop. All right, that's enough.
It looks like we've got about a 40-digit number here that I typed in, and it accepted it, and it's going to cycle through the whole thing, which is going to be a little bit too long for this video. So that's how this can run just by using the run command. You can also run it from the Elixir Shell. We'll go back into the Elixir Shell and bbhw.ex. What that's going to do is it's going to compile the .ex file. So now I can say bbhw.main1, and we're going to get world hello ... 1 ... bye from inside the Elixir Shell. If I compile that, if I say Elixir C, then
that's like
bbhw.ex, then that's going to compile that into a bean file. So now we have elixir.bbhw.bean. Now if I type IEX, it's going to load that bean file. up. So I could just say
Interesting.
bbhw.main 1, and I get world hello.
It looks like Elixir C is the same as Erl C.
Yes.
Those are both the commands to just compile the source into the Beam file.
Yes.
If you type in Erl C, it'll be the name of the file, which was bbhw, and then it'll be .beam. But I see it created a file named capital E Elixir dot, the module name, all uppercase, bbhw dot beam. So it didn't match the source file name at all.
Yes.
Interesting. I'm going to guess because Elixir lives on the beam, it doesn't want its module name to collide with any Erlang modules of the same name.
That's exactly what
So
I
it
thought.
prefixes them with Elixir dot.
Okay, because so you've seen a couple of different ways that BBHW can be actuated, both from the command line and from the shell. If I am running outside the shell, the run command is following set environment, which loads in the Elixir and Erlang runtimes if necessary in order to be able to run the Elixir command. The Elixir is the scripting engine, and it's going to be running a script called bbhw.exs. So why don't we run that from the command line? We're going to say Elixir bbhw.exs, and we'll say 3 as our parameter. We're getting a warning now that says that we're redefining the module bbhw. We have our elixir.bbhw.beam file, which I compiled earlier with the Elixir C command. That beam file is automatically loaded into the Elixir shell, as we showed when you run IEX. And this is one thing that's significant about Elixir. It's really, really big on having very, very descriptive warnings and error messages because of the feeling that we don't have enough descriptiveness, especially in the web application environment.
What's the difference between Elixir and IEX?
Elixir is to eScript in Erlang, as IEX is to Erl in Erlang.
Okay.
In eScript, if you have a function called main, it executes it.
Yeah.
It actually looks for main. Elixir, the command, the scripting engine, doesn't do that.
Doesn't do that.
Doesn't do that. The way I have this right now, okay, as you can see, this is just the module definition in bbhw.ex. It's not calling bbhw.main. It's not doing anything else, as you can see. My bbhw.exs, all it does is it includes that file. It says code.requirefile bbhw.ex, and then
it calls main.
It calls main, passing in the command line parameters. And so
because
that
you have
way,
to, because it doesn't get called implicitly like it would in Erlang.
Let's get rid of that beam file. So now I can type elixir space bbhw.exs 5.
Yes,
okay.
And it's the little stub. It's the little scripting
stub.
Does Elixir distinguish between those two extensions? Or could you just stick the import and the call to main in one file and run it?
Absolutely. Let's go back to here. If I took this and put it at the end of bbhw.ex, then I could run it in Elixir and there'd be no difference.
So why don't you just do that and not use the stub?
Because then if I run it in the shell, then it will run it the moment that the shell starts.
It just left us in the shell. It leaves us in interactive mode after it runs that.
That's exactly right. I don't need it if I want it to start executing immediately in the shell.
Oh, I see what you're saying. You want an ability to load the source file without executing it, and that's why you make a separate stub that requires it, which is an import, effectively, an import of the module, and then runs it. So you specifically want to have a source that can be loaded, compiled without executed, and then a little stub of source that will auto-execute.
Yeah, that'll run it as a script.
Choice.
Yeah.
Okay, I see what you're saying.
That's the choice I was making. So here's the code of our Elixir program. We'll take a look at the Erlang a little bit later because this is very, very similar to the Erlang version that we wrote. But let's talk first of all about how you define modules. Everything in Elixir is based on modules. This is very much true with Erlang as well. Although I'm by no means a Ruby programmer, my understanding is that people who are familiar with Ruby will be very familiar with this syntax. So modules are defined with a def module, and everything has an end. So the end of the def module is the end of the module. This way I can have multiple modules in one file.
And you have to have a module. You can't just write code.
You can just write code. One of the videos that I looked at in order to learn about how to work in Elixir does describe the complete process. Ruby is to Rails, as Elixir is to a web framework called Phoenix. And in the video talks about the whole process, how you can write things in scripts, you can write them in modules, and you can write them for Phoenix, you can write applications. We're not going to go into how to build programs the way Elixir wants to be written for the web. There are videos for that. I will put a link to one of them in the comments. Okay, we've created the module BBHW. As you can see here, module names have to be uppercase.
All uppercase?
No,
Uppercase.
not all uppercase. They have to start with an uppercase letter. It's
Okay.
just when we do something with acronyms, if I have to start it with uppercase, then it'll be all uppercase. There's a different way it's a different style, like the URL acronym will a lot of times be a capital U and then a lowercase RL. Mine will typically be all capitals for acronyms. Then we have multiple versions of main.
And you declare those by saying def.
Def. So def space main, 2 parentheses, comma, do colon, and that way it's all just on one line. If you look on line 8, we've got another main. So let's take a look at that one. You have your def space main, arg, which is your parameter, when, which is a guard clause, is specifying only when arg is an integer. And then we have do at the end of that.
But there's no comma. So as you said, you declared main, you have an arg, you have the when for the function call matching.
Yes.
But before do, there's no comma and there's no colon after the do. So there's definitely some difference in syntax there.
Here on line 13, I have the end, which is the end of my def. If you don't have,
get rid of the ends.
That's right. You get rid of the ends. So anyway, that's the difference on the single line. You have the def main left paren, then comma, followed by do colon, and then that's simply calling the function run, because that is saying I'm going to call run. There's no command line parameters. And then the second one on line 4 is another single line passed with an empty list. Okay, so we got def and then main, and then the left bracket, right bracket denoting an empty list. And then we do run again with no parameters. That means there was nothing coming in from the command line. Now, we did main a little bit differently in the Erlang video. What I did in this one is I put a couple of other single line mains where we had the guard clauses, where I have the third and fourth one where we're going to take arg. When arg is an atom, then we're just going to say it's a bad arg. Okay, this one's no good. Okay.
Can't be an atom.
Can't
we
be
don't
an
like
atom.
atoms as args. Okay.
And if it's a list, then we're going to take the top of that list. We're going to take the first parameter in the list and then pass that into main.
How did you get arg? Where does arg come from?
That's here in EXS.
So when you use
That's how I'm getting
EXS, you're literally calling the system function that gives me command line arguments.
That's right.
You're getting an array.
Of strings.
So you've got main, left paren, HD, left paren, arg, right paren. What is HD? Is that a built-in function, or
Yes,
is it?
that's a built-in, and it just like Erlang. Erlang has the same function. It pops the top argument off of a list. So on line 8, we've got our guard clause for is integer, and we're passing that integer into main. And all we're doing there, since it's an integer, is we call the function is it good? Is it good? We'll look down here. That's going to be testing to see if it's an integer that is greater than or equal to 0. This case statement here, this is very similar to what you see in Erlang. If the response to that is true, then we call the run method or the run function specifying the arg. If it's false, that means that it's not a valid one, and we call isBadArg, which is what gives us our error message. And then we have our last main method on line 15. That's the catch-all for main with a single argument, because we've We've done all the other ones. We've done the ones with no parameters up here. We've done the ones with an empty list. We've done the one that passes in an atom. We've done the one that passes in a list and taken the first argument. And we've done the one that passes in an integer. And so this is for everything else. We pass that through get countdown. And you'll notice here that in this get countdown call, there's no parenthesis here.
I do notice that.
You don't have to have the parentheses. Personally, that's
There's a
not
lot.
something I care for. I prefer to like either have them or not, you know.
Yeah, yeah. This is that. I'm getting the feeling that there's a lot of this optionality in the language. It's like, you know, depending on your personal preference, you could do it this way or you could do it that way. Or again, it evolved.
Well, you know how you don't like languages with braces because of your keyboard?
Yeah.
Right.
My Portuguese keyboard.
Well, right. Maybe that's why. Maybe some people just, you know, they don't like the parentheses. They don't want to have to use it, right? Which means they're not going to like Lisp.
Yeah.
I'd say stay away from Lisp.
Yeah.
You're not going to like that.
Yeah, exactly right.
Now, one other thing you might notice, I don't know if you've seen it yet. So we have the def main, and then we have down here the def p get countdown.
I noticed that.
Yeah.
What is def p?
Bet you can guess.
Private.
Yes, got it. One. Look at that guy. Okay, so that is how you define something that is private, that is not public to a module. So where I can call from the shell, I can call bbhw.main. I cannot call bbhw.getCountdown because it's private. Is this a Ruby standard to your memory? Do you remember that there was a def and a def p? I don't. I haven't looked at Ruby, so
you're really putting me against the wall here. I remember this is confusing me already. I look at it and I'm like, that could be Ruby. I have no idea.
I know.
But more recent language in Rust, I like some of the default choices. For example, immutability is the default, meaning if you want something to be mutable, you have to add the mute keyword, right? Versus C and C++, const is the option. The default is non-const.
Yeah.
So I much prefer languages where the default is immutability. Same thing. Rust also assumes if you don't say pub before a procedure or function declaration, then it's private.
Right.
They default to private. This feels to me like defaulting to public. I want to ask you a question. Compare this to Erlang. In Erlang, you would have to have an export declaration at the top. You'd have to define your functions, and then you export them based on their arity. So it kind of forces you to be kind of advertising or very upfront. It's extra work, but at least when you go into a module, the very first thing you're going to see is what's exported from this module. Here, you're relying on the individual definition, the choice of this def or def p. Meaning if you wanted to find all the public functions, you'd have to search through all the functions. You could have defs down below, right? Then unless you scrolled down to the bottom, you'd never see it.
That's right.
Is that right?
Mm-hmm.
Interesting choice, huh? What do you think of having it like forced in a header at the top versus, could you put export declarations anywhere?
I think the answer I would give is that that a language like Elixir that does it this way, same as C# or any other language that requires you to specify these things, that depends on the discipline of the programmer. You hope that the programmer is going to be disciplined enough to say, all of my public stuff is in a certain place and all of my private stuff is in a certain place and all my code is consistent that way. So if you want to know what I'm exporting, then just look at the top of the code because those will be the ones I'm exporting. Whereas in Erlang, you specifically have to say it at the top, what you're exporting.
On my personal preference, it's not foisted on the world. The difference between def and def p is one character. I could see easily forgetting to put the p.
Oh yeah.
Or easily forgetting to put the p down below. And suddenly I have a bunch of public things I didn't want to be public. In Erlang, I have to specifically add it to the export statement or it's not visible. I like that restriction.
When I was writing it, they originally all had def. And it was when I started to run it and I looked at it and I said, well, wait a minute, where do I define what I'm exporting? And I'm like, wait a minute, it's going to export everything. How do I make it private? And then I went looking for it and found def p, right? So that's exactly what's going to happen if you're not careful about it. And again, that relies on the discipline of the programmer. Is the programmer going to be disciplined enough to say, I want to proactively make only this stuff public, or they're just going to say, well, I don't care, make them all public. Who knows? I guess there are different
Sure.
schools of thought.
White box. I'm all
Yeah.
for the white box.
White box.
Something else occurred to me that, again, for the listeners or just for ignoramuses like me, I just noticed there are no type declarations anywhere. I see
Of
main,
course.
left
Yeah.
colon, arg. It's dynamically typed.
Again, Elixir is dynamically typed just like Erlang. Yeah. Okay, so then we get down to our get countdown method is going to take an input as a string. So S is identified as an S. You have a def P because it's private. The integer parse is going to return a tuple. Again, this is just like Erlang. So on line 24, we have the left brace, comma, I, lowercase I, space, 2 quotes, and a right brace. That defines a tuple in which we are doing a match. Once again, we're doing a match on the results of integer parse. The first element of this tuple is an integer that's going to be assigned to I. Everything after that is everything that came after the integer portion of parse that could not be parsed as an integer. So for instance, if I have get countdown, say 1 plus 2, then that's going to result in an I plus 2 will be that string. So in my case, I'm expecting to find nothing that couldn't be parsed as an integer. Then we do another case statement. Is it good? We pass in I. If that comes back true, then we return I as an integer from get countdown. Otherwise, anything else that it comes back as we just call is not good, which is our error message routine. And we specify it is not good, we specify the integer I. We don't specify what came in to get countdown as S. We do that if the integer parse came back with anything other than what we expected. Then we call is not good with a string. You've got your is bad arg now on line 32. That's called up here on line 5, where you pass in an atom. It's called here on line 11 when an integer argument passed in was not a valid integer argument. We call is bad arg. And all is bad arg does is call is not good. And is not good is our error message routine, but then it also calls run. So this is the case in which an initial value was passed into main.
Yeah.
It was not a valid value. So we do our error message and then we call run without a parameter indicating it should take input of the countdown. So that's what is bad arg does.
Yeah, it just reminds me of the Erlang. It's very similar, right? To all
Yeah,
of it.
and we're going to, like I said, we'll look at that at the end because this is all very similar to Erlang. In fact, there's really only a few differences other than the syntax differences in Elixir. Like, for instance, I mentioned earlier that Elixir allows you to do mutability, right, by what we call rebinding. I didn't do any of that. I kept it immutable.
So you're able to keep the same structure as Erlang, matching it effectively. I want to be annoying
I know
for a
you
moment. Forgive me. Yeah, the same kind of weird English to me as you had in Erlang. So you have, is it good? Which to me sounds like a question. Is it good?
Yeah.
And the other one is not good.
Yeah.
Sounds more like a statement.
Yes.
Rather than saying it is good would be the statement.
Yeah.
And it is not good.
Except, and here's the thing, is it good is a question.
But is not good? Is that not a question?
No, it's not.
Oh, wow, dude. Okay.
And is bad arg and is not good are not questions.
So, okay. That actually threw me for a loop. Okay, so this is one of the reasons why I'm not a fan of English in general, or just spoken language in programming. I like symbols for a reason.
Yeah, they're so much easier to understand.
Well, they're unambiguous. They have a very precise, exact meaning. There's no mistaking it. Okay, so is it good, you said as a question. Is not good. I think if you were going to say it as a statement, it would be like, it is not good.
Right.
Otherwise, it could be like a question.
That was the original name of it, too.
Well, what
it was actually it's not. It was actually it's not good. ITS or it's bad arg or
well,
it's
why don't
not
you just
good.
say it is bad?
Yeah, and you know what? That's a very valid argument.
This would be a great place where what you saw in Scheme that you liked, where you could add the question mark to the end of the function name. That way you would know it's a predicate.
Yeah. I had forgotten you can do that in Scheme. That's nice that you can use a question mark because that would make it easy. Anything with a question mark is an interrogative, you know?
Point for Scheme.
Yeah. Okay, so the is it good is a single line function where we're just doing a do. It's returning a Boolean value if I is greater than or equal to 0. On line 39, that's where our is not good starts. If you look down on line 43, you have our I output S invalid countdown. This pound symbol followed by a left brace followed by V right brace is actually string interpolation for insert the variable V passed in as a parameter.
Can you put any Elixir expression where the V is? So does the pound, the hash, I know we say interchangeably pound and hash, right? From the old days, we used to
Yes.
call them pound, everybody calls them hash. So hash, left curly brace, right curly brace, whatever's in there. Is that any valid Elixir expression, or is it only the names of variables?
And I'll
I'm
tell
going to
you,
guess
I
that it's
think
the former, because this is true in Rust, this is true in Swift. They just in Kotlin, and they support, like, you can embed an expression inside a string using this syntax, and then it'll just evaluate it as a language expression.
I don't remember if there are two different ones in Elixir. I know that there are a number of other languages. Like, for instance, in Bash script is a good example where the brace means a variable and then parentheses means an expression. Same is true in PowerShell. I don't know the answer to your question right now. In Erlang, this pound left brace V right brace, that could be a tilde P. That will format it with quotes if it's a string, without quotes if it's not. In this one, I was trying to accommodate that. And so on line 39, I have a match, is not good. And we have our guard clause here is Atom. You saw that at the top. In our main method, if it's an Atom, then it's a bad argument. Is bad arg is going to call is not good with that Atom as an argument. So it says, if it's an Atom, then do is not good and call to underscore string, which is another built-in. And it'll convert the Atom to a string. On line 40, we have another guard clause. It says is binary. Is binary is going to return true if it's a string. And is not good is called with the string surrounded with quotes. So it's a
binary means it's a string. Was
Means
this the
it's a
same
string.
thing as Erlang, where strings are
no.
tuples or they're lists?
In Erlang, it's a list. There is no string type in Erlang. There is in Elixir, and if you want to find out if it's a string you use, is binary. So what I do in that case, in the is not good, I have an Atom :print as the second parameter. And that is specifically to call this one. The reason was because I didn't want to do this I output S and returning error in multiple places.
It seems like you've got into the rhythm of what's unique about this pattern matching approach to calling procedures and functions. I like that because it is a distinctive way to think about writing code versus we're so used, for example, the fact that you have 6 signatures of main, right? In a more conventional procedural language, you would have written one main with a bunch of if clauses and conditions in there to say, well, if the parameter is this, then here's a chunk of code I'm going to execute. Otherwise, a big switch statement or case statement. These languages effectively externalize the switch statement or the case statement by saying, at the point in which these things are invoked, there's going to be dispatch based on variations in arguments.
Right.
And we're going to do that for you. And the structure of your code is going to show that distinction without you having to imperatively code that. Whereas if you were to do it in a more procedural language that didn't have that, it would be very imperative. It'd be like, if, switch, if it looks like this, then make this choice. Now I have to say, if it looks like that, and the ordering would matter.
We talked about that in the Erlang. You remember we talked about the difference between using an if statement and then the, what did you call it? The pyramid of death, a case within a case.
Pyramid of doom. No, that's not my term. That's just a conventional term. Scott Woloshin uses that one.
I like pyramid of
the
death.
Pyramid of
better,
doom.
Yeah.
Death is better than doom.
Like death is better than doom. So anyway, that kind of describes why I did this way. I wanted to see strings surrounded with quotes. And then, of course, we have found where that fell down when we put in a float. Wait a minute. I got a question. Let's go back and look at the shell again.
Yeah.
I'm in IEX right now. So if I say bbhw.main 1.1, oh,
I thought you entered a float before and it worked. Did you change the code?
on the command line. Remember on the command line I did, that's going to come in
as a string.
That's coming in as a string. Okay, so this part right here, it's going to fail the integer parse.
This is an example of where function invocation pattern matching failed to make a match.
Which means it's not an atom, it's not a list, it's not an integer. So it went to here and did get countdown and went down to integer parse with a 1.1. So let's see what happens.
It's not a string and it didn't like parsing it from a string to integer.
Yeah, probably if we had like an is float. I don't know if we have an is float, then I could have done a main thing with that. Maybe we could simply try it. Let's see if we... All right, if I put that in, okay, now let's do it. bbhw.main 1.1, invalid countdown 1.1. It worked. So there you have it, democracy in action. And that was because we added this
is float.
And and we did that on the fly, so that's cool. Okay, so we haven't seen the read input method yet because from outside itself, it's only called in one place, and that's in our run call. When we have main called with no parameters from the shell, or if we have main called from the command line with an empty parameter list, then we call run with no parameters. The run method with no parameters defined down here as a def p run left paren, right paren, comma, do, colon, and then it calls run, left paren, passing in the results of the function read input. Read input is doing a case io.getS to prompt the countdown. Yeah. We're piping the output of io.getS into string trim. Now, that has some advantages. That piping symbol is extremely powerful. That is something that I really would add. While I might prefer most of the syntax of Erlang to Elixir, I love that pipe symbol.
Why?
Because I like being able to chain the output to an input. It's that simple.
Well, let me ask you in this case, because, yeah, I can think of a lot. I like the pipe too. Just I'm playing kind of devil's advocate. In that case, you could just put the IO gets inside the parentheses of trim. You know, you could do it nested. So it doesn't do as much here. But you wanted to show an example of using the pipe?
Yes. It was the only place in the code that I could show that example of using the pipe without much more significant rewrites. So line comes in as the catch-all from the string trim. With that, we call the get countdown from the input. That's going to try to convert that to an integer. If it gets an error, then it's just going to call read input again. So if it comes in, the response is an empty string. If it's something that can't be converted to an integer, then it's going to call read input again, and that's tail recursive. The results of read input are going to be not only an integer, but it's going to be a valid integer because it's going to have gone through all of our other validation checks.
I noticed something here. If you enter nothing at countdown, I can see here you're just going to ask countdown again. You're not going to say it's an error, right? If they just press enter, they enter nothing.
Yeah, and that's I wanted it set up to where if they passed in just the empty string, if they pressed enter, it just said, give me the countdown. Didn't you hear me? Give me the countdown.
So should we make that the UX? So if there's nothing entered, it just
asks for countdown.
It doesn't say invalid.
Right.
Okay. It just gets repetitive and annoying. Give me the countdown. Give me the countdown.
So run with no parameters calls run specifying the results of read input. And that's on line 59, where we run and we bring in count, io.write hello world, or world hello. Now, io.write is not going to put in a line feed at the end of the line, but io put s does. And then we call rundown. On line 66, you have the def p rundown count, We call an IO write, again, not appending the carriage return. Pound, brace, count, write brace, which is string interpolation, embedding the value of count, followed by period, period, period. And then we call sleep, which is part of the process module to tell it we want to sleep for 1 second. And then we call rundown again. That's count -1. Again, it's tail recursive, which is why we could pass a huge number into rundown and it will work and it will never run out of stack because it's tail recursive. On line 65, we have the rundown pattern matching to the 0 being passed in. All that does is return the OK atom. And when rundown hits 0, then it will just return OK. And that's the whole program. Very much like Erlang. It's declarative and it's functional.
Yeah, so looking at rundown, I have a couple comments.
Okay.
So I saw that IO and process and string and integer, and in the EXS, the stub, we saw system.
Yeah.
These all look like modules that I'm going to guess are automatically imported.
That's my
And they're
guess.
probably, it's a bundle of, it seems to me like the standard library is a bundle of modules.
That's possibly true. I can't tell you definitively because I haven't studied the language enough to know that. It could be that there are just a whole bunch of automatic imports that go in. Taking that away from the programmer and just assuming that's what he wants. Those things are both good and bad. Being able to get started with Elixir, then yeah, it's good to include all this stuff. Just like in BBHW, we're trying to show a set of rudimentary functions that an interactive program might need to use. You want to take input and you want to write output, whether it be to the console or something else. So that kind of stuff is included. Maybe you want to do things with strings, you want to do things with integers. So we bring in all of those things automatically. So do you have any other final thoughts on this?
Yeah, it's the same thing that I had when I was looking at Erlang, in that if I've made versions similar to this in other languages, like in J. This would be to me the most subdivided, right? Because if you look at the logic, like when we looked at Scheme, the Scheme implementations I did were the least subdivided.
Yeah.
Right. It was just a linear flow of expressions that would execute.
Yeah.
There were no separately defined functions. None of it was functionalized or isolated. This variation is a very subdivided variation. And I like the idea that we present multiple varieties of ways to do, so we can show the different styles even within a language of how to code for different preferences. And then as the primary author, such as yourself, you pick which one you think should be the most idiomatic, the most defaulted, or whatever. Like the main, like an example for the mains, I'm wondering if there's a way you could make the second two mains single liners. I like down at the very bottom, like go down to the very bottom, the very, very bottom, scroll down. Okay, so the final rundown and the final run functions. So you've got two declarations for each of these. But what I like about it is that the pattern match where there's no input or there's a 0 count is a single line right above the happy path, right? Those are kind of the unhappy paths, and then you got the happy path. And if you were to write that without pattern matching, it would literally just be a single function where the very first line would be if rundown is 0, return, or the whole body would be if not 0. So it looks very close to a non-pattern matching function with imperative code checking in the beginning of it. This is just doing it in this pattern matching style. And I was looking up above at the mains, and I'm like, well, I like that the mains kind of show you that's essentially the externalized switch statement for main, but the other two, they really stick out. Like they don't fit the pattern.
Here's what I'll say about that. On the one line thing, you could do the pattern matching on the other two. You just have to call other functions.
Well, you would take your case statement. Yeah, you would make it a separate function.
But the problem for me is it would be a single call function. And I really don't see the purpose behind a single call function. Like let's take, for instance, the main on line 9 here. We've got an is integer guard, where what would we do? Call something that says process integer. But nobody else is going to call process integer.
Yeah, no, that's a good
So you
point.
got one function is going to call it. Why do that? Yeah. Just put it in there. I pretty much live by dry. If I'm going to do it more than once, then it's going to be in a function with very little exception. But if I'm only going to do it once, then I'm not going to have it call someplace else just because I want it to be a function.
I like that the lines are all very short. You're all under 80 columns on all of it. Remember we had that discussion last time
Well,
around?
yeah, and the truth is,
So that was nice.
I have generally kept to about 80 columns, but you mentioned
Yeah.
that you like to have multiple things on at one time. So that's when I just started. I started doing that with everything. I'm
I've
using the
influenced you.
80 column.
Um,
Well, I used to do that because, the monitors that we used to have, it just became a habit back then.
well,
But
I
when,
work I work on a laptop a lot,
and you
and
work
I
on
need
multiple screens. I've seen you do that.
and
Yeah.
I have bad eyes. I need my fonts to be pretty big even when I'm working.
Okay, so the last thing, let's take a look at the comparison between the two. So on the left side, we can see the old Erlang, and this was, I didn't make any of the modifications to this one that we talked
Right.
about before. I added more pattern matching on the right. So whereas in the main method on line 14 in the Erlang down here, it's actually got an if statement. It goes through and
Yeah.
if it's a string, if it's a list, if it's an atom. Based on some of the suggestions that you made, I converted that to do pattern matching with the mains here at the top. And that worked out really well. I think it worked out better and we got rid of the if. I think largely the reason that I did it the way I did in Erlang before was to demonstrate the if statement if you wanted to use that.
Right.
But for the most part, other than the obvious changes, right? What are the fundamental differences between the two? You notice in the Erlang, there's no def, right? In the Erlang at the top, we have our module statement. There's only one module per file. And we have an export statement. We're having to export specifically the main method with 0 parameters and 1 parameters. Elixir has got the def statement. Anything with def is public. Anything with def p is private. In Erlang, anything you don't put in an export statement is private. In Erlang, all variables start with an uppercase letter. In Elixir, variables start with a lowercase letter.
So arbitrary.
It's because module names start with an uppercase letter.
Of course.
In Erlang, a function is defined by specifying the name, a parameter list, and then a dash right angle bracket. And then all statements are separated by commas, and the end of the function is determined by a period. Other than the syntactic differences, one of the things that you'll see is here on the get countdown method in Erlang, you can see that the string :2 integer, that's the string module. In Elixir, that is integer.parse. The string to integer parses it out. It takes as much of the integer in the string that it can. Anything after that, it returns as a list of characters, which is why in the Erlang, you see that as 2 brackets rather than an empty string as you see in Elixir. The is not good down here, another significant difference, where this $p in Erlang that says take this value and do it in the format that's valid for whatever that variable is. If it's a float, no quotes. If it's a string, quotes. It handles it for you. I was trying to demonstrate how to do that with multiple matchings of the function is not good. Other than that, fundamentally the same.
Let me ask you a question. For you, does Elixir offer sufficient improvements over Erlang to motivate you to use it instead of Erlang? Whether that's syntax, functions, pipe operator, does it? Is there enough there, enough of a difference, and enough of a difference that matters to you?
I like the pipe symbol.
Right?
I like the lowercase letters for variables, and I like the colon for atoms. But primarily, I would say, and I like that string is a type for working with stuff like. I think that's handle things a little bit easier. But at the end of the day, I can live without all that stuff in Erlang, and I like that Erlang is a lot less verbose. The one thing I did not miss at all, and I don't know if I would, was the mutability that you get in Elixir. I don't know that would matter to me at all. At this point, I can't imagine a situation where it would. I like the idea of programming immutably.
I agree with that. And we're building currently so far Proglang base using Erlang. So it'd be interesting going forward as we work on it together and we do more Erlang code. Since you have some familiarity with what Elixir has to offer above Erlang, It'd be interesting to see if you're drawn to it more or still feel like the juice isn't worth the squeeze. That's my take on it, looking at it right now. The added complexity of, I know it sits on top of the beam. I know the Erlang is built natively into the beam. So you're definitely piling on a lot more stuff. There's a compiler. You didn't even really go through mix, which we don't need for Bye Hello World, but I'm kind of glad because for me, that's not something that's appealing. I'm not into package-driven development and complicated build tools. Now, as our project grows and scales up, maybe those things will become more attractive. I've yet to see. But at this point, if you had to ask me for what I'm building so far in Proglang base, does Elixir offer anything? I'm going to agree with you. The pipe operator is nice. I'd like to have that. Is it a deal breaker? No. Strings, true strings? I guess I'm going to have to see how far we get just dealing with the stringification that we get from Erlang and whether it's annoying enough that it's a problem. The syntax certainly isn't more appealing to me. So I don't see enough for me at this time to be motivated to go to Elixir.
I think you had it.
I would much more likely go to LFE because I immediately know that there's things about Lisp that I like.
The last comment that I'll make about this question is I tend to agree with you. I think at the end of the day, for the modern web application developer, Erlang is not a commonly known language syntax. And Ruby is. And I think Jose was looking at that and he said, well, I'm going to bring that Ruby syntax over to a highly concurrent and reliable environment that you have in the Erlang runtime.
Yeah, I'm going to agree with that. I think the primary motive was to bring, as you're saying, the syntax over because it brings all those programmers over.
Mm-hmm.
Ruby programmers, not Ruby code, and not necessarily a syntax that would be more appealing to people who haven't programmed in Ruby. It's specifically, there's a whole mass of Ruby programmers. And Jose, to your point, is saying, hey, we can bring these people to the beam. This is how to do it. It'd be much harder, too high a barrier to try to get them to go from Ruby to Erlang.
Yeah, I think that's really what it was. I think he looked at it.
Yeah.
I mean, he's a Ruby guy. That's true. But, he's a pretty sharp guy. And there's a lot of people using Ruby. So this is a way to get these people over to a concurrent and highly fault-tolerant environment. And he succeeded because, the Elixir Phoenix environment is massive. There's a tremendous user base out there now.
It's growing. It's definitely growing.
Definitely growing.
I would like to see you, or me, or somebody, but you, if you're up for it, to do a condensed version of the Erlang and the Elixir. Try to de-subdivide it and see if you can preserve its essence while doing that. If it has to be subdivided, that this is the idiomatic way to do it. Because it's a lot more scrolling, it's a lot more reading, it's a lot more words. Visually, it's not so much the number of words that I see that bothers me here. It's just with the more tacit versions, I can follow the flow of the program from top to bottom. I literally can just go, it goes here, then here, then here, then here, then here. It might loop in here, and then it goes there, and it's done. It's like a straight line.
Here's the sad.
I don't see that straight line here. I see jump, 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 and my mind is having to do parkour to get its way through the flow of this program.
Well, kind of the nature of modular development, but
depends on where you make the modular boundaries and then how you organize them.
I can try. I would start with doing it in Erlang. I wouldn't try starting that with Elixir. But, and I'll tell you why. Part of the reason is I'm not sure it can be done immutably to do it the way you want to see it, which is more, top to bottom. Side? Yeah, or on the Erlang side. I'm not sure.
You have to do it immutably. You have to do it immutably on Erlang.
I know. I'm not sure you can do it immutably the way you're talking.
Okay. All right.
To have, for instance, one main method, and you're going to have a lot of ifs and a lot of nested case statements. I think that's going to be challenging. And for one thing, you're not going to be able to do it with the read input because that by nature is, how are you going to do that? There's no for loop. There's no,
right.
I'm not sure how you do that. There's
you have thrown down the gauntlet and I'm going to do it. I'm going to take your Erlang version and I'm going to try to condense it down.
All right.
Erlang will do lambdas.
All right. Then I'll be very interested in seeing that version. So that's something to think about for us for next time. But for me, I'm going to go on and look at doing something in LFE. So I'm happy for you to go back and do a condensed version of Erlang. I look forward to having that discussion.
Yeah, it's going to be fun.
All right. Okay, everybody, thanks for watching. And until next time,
The best of luck.